Hello students, Professor Watts here. Welcome to Homework 3 for International Business. And in this assignment we're going to use a spreadsheet to create a model for the 3 foreign exchange hedging procedures that we studied previously. That's going to be using either forward markets, money markets, or options markets to try to minimize the risks of adverse moves in the exchange rate and also retain the ability to benefit from favorable changes in the exchange rate. And I'll refer you back to my video, Hedging Forex Exposure. That's the lecture video where we covered this stuff, so you'll want to have watched that before you go through this video, because I'm not going to walk you through the entire procedures again. I'm going to assume that you kind of have a background of what we're talking about. So watch this if you haven't yet, or maybe review it if you feel a little rusty on it before proceeding with this homework tutorial. Okay, so the first worksheet in here is called Forex Hedging Mod, and what we're going to do here is create a model, and I've kind of templated out for us already, so we're just going to enter some data and then the math. The math is going to be the tricky part, but the nice thing about this is that the math will always be the same, so we can run this model again and again and again for different scenarios and then just input different data. So these kind of tan colored cells here are going to be the potential relevant data we'll need for every situation. And then over here, in these dark blue shaded cells, we're going to have the outcomes for every possible scenario, including not hedging at all, and just seeing what happens to the sum of money received or paid based on an assumption about what the future exchange rate will be. And then we can use the forward hedge, find out what the outcome is there. We can use the money market hedge, find out what the outcome is there. Use an options hedge, find out what the outcome is here. Now over here I've kind of written down in words and math symbols what we're going to be doing in each of these cells, and as we walk through that, as we build those, I'll kind of explain the logic. Some of the things are really simple. Remaining unhedged is pretty simple. It's just the amount of money times the exchange rate. Some things are going to be a little bit more complicated, and we'll start using Excel's logic functions to work out multiple possible scenarios, because the math here is going to be different whether we're dealing with a receivable or payable. Okay, so in these boxes here where I've kind of shaded in pink, we have the textbook example that I also used in the lecture on foreign exchange hedging. So let's go ahead and populate our data with the data from this example. We have Boeing exporting 737 landing gear to British Airways and billing 10 million pounds payable in 1 year. So that's going to be the amount of exposure. Notice here I say that's in the units of the foreign currency. So we won't put any symbol with that, because that could be pounds or euros or Swiss francs or yen or whatever. So we'll just type that in as a number, 10 million. I've got that formatted with commas and no decimals. Okay, then the current spot exchange rate, that's given in our problem as well, $1.5 per pound. Notice that these are going to be in American terms for all of our exchange rates: spot, expected future spot, and forward exchange rate. So this is the current spot rate, which is 150. I've already got that formatted as dollars, $1.50 per pound. The expected future spot exchange rate, that's not necessarily given in each problem, and if it's not, we'll just go with the forward exchange rate of 146 for that. That'll be kind of the market's estimation of the future spot rate, and of course that's going to be the value for the forward rate as well. Okay, now are we dealing with options? Possibly. Now, whether we're dealing with call or put depends on whether we're looking at a receivable or a payable. This is from Boeing's perspective, and Boeing sold the parts and billed payable, so it's payable to British Airways, but we're looking at Boeing's perspective here. So that's going to be Boeing could hedge with options by buying a put, buying a right to sell that foreign currency at a set price. So we're going to only enter data for the put option here, and if you read the second panel here, that's the option scenario. We have the put option details. So exercise price of $1.46 per pound and a premium of 2 cents per contract. Okay, so the call option will be left blank here because this is a receivable. Now, payment type, we're going to type in receivable or payable, but one bonus thing I want to teach you here is how to use validation. So only one of a set range of possible values can be entered here. And those values, we can just go anywhere else in this spreadsheet. I'll just jump up here to the top and we'll enter the options we want to limit this to. So I'm going to spell out the words receivable and then one cell down, payable. And what I'm going to do is click on the payment type, and I want these to be the only options available to enter here. So I'm going to go up to the Data tab, Then slide over here on the ribbon to this little doodad right here. It's called Data Validation. Click the drop down, select Data Validation, and we're going to allow a list. And the source for that list is going to be those two cells we just specified, so that'd be F1 and F2. And now notice Excel's going to give us a drop down. We can list that as either receivable or payable, and we can't put anything else in there. Notice if I try to type something else, it doesn't let me do it because it's validated to these options. Now, one thing I like to do when I do validation, as I don't like those to be visible, is I'll just select my data validation range, and I'll change the text color to white for those. They're still there, but they just don't show up. So they're kind of hidden in plain sight, as it were. So now we can list that as a payable or receivable. This one's a receivable because, again, we're looking at Boeing's perspective. Okay, term of exposure, this is going to be important, fraction of a year. Now you might notice here that this is specified in a couple places. It's payable in 1 year, the options are 1 year, so we're just going to list that as 1. This is going to be 1 or less for, or we could go 1 or less. Half a year would be 0.5, 3 months would be 0.25, and so on. Okay, then the interest rates. U.S. interest rate is listed here, 6.1% per annum, and then the foreign interest rate, which would be the UK, here is 9%. Okay, so that's the data. That's pretty easy. Now we want to set up the model and do some math. So what's option 1, remain unhedged? Well, that's just going to be the amount of foreign currency we're exposed to times the expected spot exchange rate. Okay, notice that's the expected spot exchange rate that we're going to face at the end of the term in which this payment is either going to be received or due. So that's going to be $14.6 million if that $1.46 per pound exchange rate prevails. And of course, as we change that, let's say we had an expectation based on our own intelligence that the pound was going to appreciate in terms of the dollar, then we could just plug a different value in there, right? I'll just undo that and leave what we had. Okay, now let's look at the forward hedge. The forward hedge is pretty simple as well. We're just going to sell that 10 million pounds forward at the forward price. So that's going to be equal to the exposure on the foreign currency times that forward rate. Okay, easy, nothing to it. And then again, as the forward rate changes, we could just plug in a different value for the forward rate. What if the pound's going to depreciate against the dollar down to $1.43, let's say, and that changes to 14.3 million. Control Z, undo that back to where we were. Okay, now is where things start to get a little bit more complicated, so you want to follow along closely. If needed, you can pause, you can rewind. But I have spelled out exactly what we're doing math-wise over here. And I want to just maybe, before we run this, kind of walk through the math here. So, what are the elements of the math for the money market hedge? Okay, so we're taking the amount of foreign currency that we're exposed to, and we're dividing it by 1 plus the foreign interest rate times the term. So you can think about this as the discounted present value in foreign currency at the foreign interest rate. So this is what we would have to borrow today in order for it to mature into the amount of foreign currency we're going to be receiving at the end of the period. And what we're going to do with the receivable here is we're going to borrow in the foreign currency amount less than what we're going to be receiving, and it's the amount less than the amount we're receiving by the factor it would grow to if invested at the foreign interest rate. And that way our receivable instantly will be used to extinguish that foreign debt. In the meantime, while we borrowed that money in before it's due, we're going to go ahead and convert it into our own currency, our domestic currency, at the spot exchange rate. So that's what times spot means here. And then we're going to invest it at our own domestic interest rate. So that's multiplied by 1 plus the U.S. interest rate times the term. So this is the future value, we should say domestic. So when we invest this domestically, that's this right here. So we convert it. I'll list this as 3 pieces now. So present value foreign. So that's setting up a amount borrowed in the foreign currency, which will be extinguished by the receipt of the foreign currency due. We're going to convert it in the meantime at the spot exchange rate, and then invest it domestically at our own interest rate. And if we plug all of that math in, and we can do all of that in one kind of big, messy formula, Excel will tell us exactly what that will result in. So let's see if we can run that. Okay, so note the parentheses here. Order of operations is paramount. Exposure divided by parentheses 1 plus parentheses foreign interest rate times the term. And notice I'm using cell references for everything except the one component there. But when possible, use cell references. That way when we change the cell references, Excel updates it automatically. Minimizes our work, maximizes our accuracy. Okay, I'm closing out everything there. Times spot exchange rate, current spot exchange rate, times parentheses 1 plus parentheses US interest rate times the term, close the parentheses, close the parentheses. Okay, so that's what it's going to look like. Press enter and we're all set. Okay, now that was a little bit of math, but we know exactly what we're doing, so we can just kind of slow down, take our time, make sure we enter things correctly. Options Hedge is going to be a little bit more hairy, so let's kind of walk through what's going on there. Now we're going to use if functions based on whether this says receivable or payable to trigger which math will run, but let's just look at what math we're running here kind of individually, and then we will plug it all in. So if we're talking about a receivable here, what's the option strategy for a receivable? Well, we want to buy put options so we can lock in the price that we could potentially sell it at if needed by exercising the option at some floor, some threshold. And then of course if the spot exchange rate at the time we receive the foreign currency is higher than that, well, we just let the option expire and sell the foreign currency at that higher spot price that's realized. If the spot price goes down, we're protected. Remember, we have a floor and we could sell it at the option exercise price, but we have to work into our analysis the fact that we have to pay a premium for the option up front, and we want to work out the opportunity cost of that, the fact that instead of buying the option we could have invested that at the domestic interest rate. Okay, so we're going to start with the exposure, the amount of foreign currency we're getting here in this case with receivables. Okay, then we're going to multiply that by the put exercise price minus the put premium. This would represent the net received from the option. Okay, and then we're going to subtract from that the put premium times the exposure times the US interest rate times the investment term, and all of this over here is going to represent the opportunity cost of the option. So what we give up by the amount shelled out for the option, basically what we could have gotten if we had invested that domestically. Okay, so that's actually not too complicated. It just looks complicated. Now, what about if we're dealing with a payable? Well, the way of hedging a payable with options is going to be buying call options. And that enables us to purchase the foreign currency we need to pay our bill at a guaranteed price. And then if the market price, the spot price, is below that guaranteed price, well, we'll just let that call option expire. We'll buy the foreign currency at the cheaper prevailing spot rate. But if the foreign currency appreciates, that's when we exercise the option. We're protected from the foreign currency going up and up in value and having to pay more for it when it's due, when we need to buy it in order to hand it over to the foreign counterparty that we owe that money to. So same kind of math here. We're going to take the exposure amount of foreign currency we owe in this case, multiply it by the call exercise plus the call premium. So that's going to be like the gross we're paying for the option for the foreign currency. And now we're adding the call premium times the exposure times the US interest rate times term. And again, this is going to be the opportunity cost of the option. And this time we're adding it because we're adding it to the cost of paying for the foreign currency that we need to come up with to satisfy our account payable in this case. Okay, so how do we do this? Now we're going to run an if function. Be an if function. If the logical test component is if the content of F5, so we're just going to click on F5, equals the word, and notice that this has to be within quotation marks, receivable, end quote, comma, value if true. If that's true, we're going to run this top line here. So what is that? Exposure, that's the 10 million pounds, times, now again note the importance of the parentheses here, the put exercise price, that's down here 146, minus the put premium, so there's our net received after the option, minus then the opportunity cost component, which is going to be the put premium, times the exposure, so that's that would be the total we paid for the option, and then that's going to be times the US interest rate times the term, all of that in parentheses, and that represents the opportunity cost. This entire piece over here represents the opportunity cost of the option. Okay, so that whole thing is the value of true for the option, comma. Now we need a value of false for the option. So what I like to do here, now we could just run the bottom line here, because if it's not receivable, it's going to be payable, right? You also could just run another if function and make the value of true, make that set to payable, and then make the value of true the bottom line, and then make the other value nothing, make it null. So I like to do it with another if function just to make sure I'm fully specified. So that's what I'm going to do. I'm going to say if F5 this time equals quote payable end quote, comma. Now we're going to run the bottom line here that I underlined in red, so it's the exposure again, times call premium. Now there's nothing there, and of course it's not going to run this because we're going to leave it as receivable, but I want to specify this just in case my scenario happens to be a payable scenario. Then I don't have to set up the model again, I just have to plug in the appropriate data, and you'll see why that's going to be handy here in a few minutes, I think. Okay, so exposure times the call exercise, there we go, C18, plus the call premium, C17, plus the call premium times the exposure amount times the US interest rate times the term, end parentheses. So that's the value of true for the second if function, comma. Now the value of false for the second if function will just be quote quote. That's nothing. That's just going to show it blank. So if there's nothing there, it'll just show nothing. I'm going to close the parentheses. That closes my second if function. Another parenthesis closes my first if function. If you get stuck up on this, just pause the video and just take a look what I have up here in the formula bar or what I have in the cell. Press enter. Now we've worked out every possible scenario, and we can say which scenario leaves us in the best position, and here it's going to be the money market hedge, just by a hair. Comes out a little bit better than the forward hedge or remaining unhedged. Okay, so let's jump over to, this is now straight out of the textbook, problem 8.2, so let's jump over to that next sheet. And we have a scenario here that we want to run, but in order to do that, we're going to need to create the model over there. So what are we going to do? Well, I'm just going to copy my formulas here from column J, Control C. I'm going to copy them, paste them over into here. Now that's not going to show up because we don't have the data populated yet, but now we'll go ahead and populate the data for problem 2. So I'm going to walk you through problem 2 and problem 3 and then problem 8-8.4. I'm just going to leave that to you to try to do all by yourself, but hopefully you'll have the hang of it, copy the model, and you can just plug the data in. It's going to be pretty straightforward, I think. Okay, so let's see if we can run this one. It says IBM purchased computer chips from NEC, a Japanese electronics concern, and was billed 250 million payable in 3 months. Okay, so let's enter that in. 250 million yen payable. I've already got the validation set here. In 3 months, so that'd be 0.25 years. Currently the spot exchange rate is 105 yen per dollar. So let's plug that in. But we want this in American terms. We want this in dollars per yen, not yen per dollar. So that's easy enough. We can just divide that. 1 divided by 105. So that's approximately 1 cent. It's actually just a hair less than that. If we showed more decimals, it'd be 0.0095. Okay. 3-month forward rate is 100 yen per dollar. So that's going to equal 1 divided by 100. That's going to be 1 cent. Show 4 decimals here if you like. The 3-month money market interest rate is 8% in the United States. So that's the annual interest rate for 3-month money, 8%. And then in Japan it's 7%. We'll just plug in the data in. Management of IBM decided to use a money market hedge to deal with this yen account payable. Okay, so we don't have any data. We don't need it for the call option stuff. So this is just going to be, all right. So to explain the process of a money market hedge, compute the dollar cost of meeting the yen obligation. All right, so the money market hedge value is computed for us here in cell J9. So explain the process. Well, let's just think about, we don't have to write anything down, but let's just think out what's going on here. So we are taking the 250 million yen, and we're dividing that by 1 plus the Japan interest rate, so 7% at 1/4 of a year. And we're basically, remember, saying what's the present value that we'd have to borrow today to come up with, to invest at the Japanese rate of 7% and come up with 250 million yen in 3 months. Right, and we could break the equation down. We could say 250 million yen divided by 1 plus the Japan rate times the term. So we'd borrow 245.7 million yen basically. And then we're going to convert that. So let's write it down like this. Borrow, convert it to dollars at the spot exchange rate. So that's going to be, let's show that as dollars, $2.34 million. And then let's invest that in the US. So that's going to be that times 1 plus the US interest rate times the term, 2.386. Okay, so that's what I was doing all of that in one big process here. I just broke it down into 3 individual steps down here. So there's the process. The dollar cost of meeting the yen obligation ultimately winds up being 2.386 million. Okay, then it's asking us to conduct a cash flow analysis of the money market hedge. So let's think about what's happening down here. And we have to remember, because this is a payable, it's kind of, we're flipping things around. The math's the same, but it's kind of like the sequence of events is different. So what we're ultimately doing here is we're basically saying, how much dollars would we need today to acquire the amount of yen we would need invested at the Japanese interest rate, such that that investment would mature at the 250 million yen that we're going to owe here in 3 months. So basically the cash flow here is we're going to invest, we're going to take $2.34 million here, convert it to yen, invest that, and that's going to buy us 245.7 million yen invested at 7% in Japan. It's going to yield us 250 million, which we owe in 3 months. But the cost of that in terms of dollars is actually $2.386 million, because there's an opportunity cost of investing that at the higher US interest rate of 8%. So what's the cash flow sequence here? Well, the cash flow looks like this. We start by shelling out the $2.340 million on day 1. Then we convert that to yen, invest that yen at the 7%. And then on day 90, at the end of the 3 months, we pick up 250 million yen. Use the 250 million yen to extinguish our obligation to the Japanese company. So the cash flow part is kind of straightforward. You don't need to actually add anything to the assignment for that. So let's move on to 8.3. This one says you plan to visit Geneva, Switzerland in 3 months to attend an 3 months. We know the term. That's going to be 0.25. Okay, to attend an international business conference. You expect to incur a total cost of 5,000 Swiss francs. So that's going to be our exposure. So let's enter that. For lodging, meals, transportation. As of today, the spot exchange rate is $6.6 per Swiss franc. So let's enter that there. The current spot exchange rate. The 3-month forward rate, that's going to be here, is $0.63 per Swiss franc. You can buy a 3-month call option. Okay, here we go. Call option. Strike price is 64 cents per Swiss franc. The premium is 5 cents per option. Assume that your expected future spot exchange rate is the same as the forward rate. So that'll be 0.63 right here. 3-month interest rate is 6% per year in the US and 4% per year in Switzerland. Okay, so this is going to be a payable, isn't it? Because we're going to go over there and spend that money. So plug that in as a payable. And now we're ready to go. And again, do we need to do all that math again? Well, I don't think so. This is the beauty of an Excel model, people. We're going to copy and paste. We're thinking about how are the different ways to finance the 5,000 Swiss francs we're going to need in 3 months. Well, we could just remain unhedged and say when we get there, we think the price of Swiss francs will be 63 cents each, so we'll just pay 63 cents each. It would be a total of $3,150 for the 5,000 Swiss francs. Okay, if we think the forward rate is the same as the expected future spot rate, well then using the forward market wouldn't have any advantage, would it? Locking that up by buying it forward right now, you might as well just wait and buy it spot because there's no difference in the price there. Now that would make sense if the forward rate were lower than what we expected the future spot rate to be. So for example, if the forward rate were 60 cents per Swiss franc, then buying it forward would only have a net cost of $3,000. Okay, the money market hedge. Well, that only has a cost of $3,015. What's the reason for that? Well, look at the interest rates. I'm going to break down that money market thing the same way I did over here in problem 8.2. So I'm just going to copy. So here we're basically saying we need 49.50 Swiss francs. If we invested that at 4%, the Swiss rate for 3 months, that would turn into 5,000 Swiss francs, which is what we need. And to fund that with dollars would only take $2,970. That's the 49.50 Swiss francs at the spot exchange rate. So that looks more attractive. 29.70 looks better than any of these, but we have to realize that the 29.70 has an opportunity cost, and in this case the opportunity cost is at this higher US interest rate, so we could have invested that at 6% US interest. So that's what I'm calculating right here. So the total cost of that is only $3,015. Now here that still looks more attractive than the 31.50 using the forward market. Let's finally think about the options hedge, and that's what they're asking us to think about in the actual question. Okay, so we're using call options. We can buy the guaranteed right to buy the Swiss franc for 64 cents, but we have to pay 5 cents for that. So that's kind of like buying the Swiss franc for 69 cents effectively. And we think the Swiss franc's only going to cost 63 cents in the open market. So of course this is going to cost more. We're adding in basically the 1 cent for the exercise price and then the 5 cents for the option. So that's going to cost us 6 cents more times the 5,000 Swiss francs. What's that going to work out to? 0.6 times 5,000. That's going to cost us $300 more. And yeah, that's about what it is. It's roughly $300 more than the 31.50 forward market price. So the options here would be in last place. The money market comes in first place. The forward hedge in second, and remaining unhedged really is pretty much equivalent because we don't expect there to be a change in the exchange rate. Now, okay, let's look at item C. At what future spot exchange rate will you be indifferent between the forward and option market hedges? Here is where we can use our old friend under the data tab, what if analysis, the goal seek. We can use the old goal seek here. Okay, so what we're going to do is set the forward hedge amount, which is in J7, equal to 34.54, which is the value of the options hedge, by changing the forward exchange rate. Here we're going to use the forward exchange rate because that's what we're plugging in there for the forward hedge value rather than the expected future spot rate. And Excel immediately calculated that out to 69 cents spot exchange rate for the Swiss franc. So if the Swiss franc we're going to the forward market rate were 69 cents, then the option scenario would be just as attractive as the forward market scenario. Okay, so that's 8.3. Now 8.4, like I said, I'm going to leave that for you to do on your own. Main thing is to populate the model correctly, populate the data correctly, copy over the model, and then analyze the two hedging alternatives here, which is going to be forward or money market. And then it says what alternative would you recommend and why. And I'm going to have a text box in here for you to type in your answer for that. And then part B, other things being equal, at what forward exchange rate would Boeing be indifferent between the two hedging methods? For that, I want you to use goal seek and see if you can have goal seek find the different forward exchange rate that would equalize the two results over here in the hedging outcomes. And I'll have a place for you to write that down in the text box as well. And then once you're done with the goal seek, just hit cancel so everything reverts back to the original data you entered. All right, best of luck with that. Please contact me if you need any help, but I think this whole assignment will be pretty straightforward.